Hello calculus students and general seekers of truth. In this video we will continue our study of the derivative of the natural log function, ironically by working on some functions that don't have natural log in it, but it is related. So we are going to take not a direct approach but an indirect approach. And I consider this, kind of like a sneaking up on the function. So let's see what I mean by this. So in number one, I have h of x is equal to 3 to the x. But rather than taking the derivative immediately, I take the natural log of both sides. So the natural log of h of x is equal to the natural log of 3 to the x. Now let's not focus so much on why I do this, but for the moment on how this works. The two sides of the equations are equal, so therefore the natural log of each side must also be equal. And then I can take an extra step here. I can apply the power rule of natural log and bring the x out to the front. So now I have x natural log of 3. On the other side, I still have the natural log of h of x. And then now I can actually continue this problem by taking the derivative. So the derivative of the right side is just going to be natural log of 3. Now the reason for that is that the natural log of 3 is a constant. So you have a constant times x. Therefore the derivative of the constant times x is just a constant. On the left side, we apply what we know from the previous videos about natural log. It is 1 over whatever is inside the natural log function times the derivative of that function. Because remember, this is two separate functions. This is h of x wrapped inside of the natural log of x. And then I can conclude this problem by simply solving for h prime. So h prime is going to equal h of x times the natural log of 3. But what was h of x from the very beginning? H of x is just 3 to the x. So that means h prime is equal to 3 to the x times the natural log of 3. So that's our final answer here. And I hope you can see what I mean when I say sneaking up on the function. Right? Rather than taking the derivative directly, we do some extra work to it. And the derivative, h prime, comes out from using the chain rule. All right, so let's do another one here, number 2, and we can apply the same concept as before. We take the natural log of f of x, and that's equal to the natural log of 4 to the x. And then just as before, I can apply the power rule of natural log and pull the x out to the front. And on the left side, still the same, the natural log of f of x. And then I can take the derivative of both sides. So the derivative of x times a constant is just that constant, in this case, natural log of 4. On the left side, I have 1 over f of x. Okay, so I'm working with the derivative of natural log times the derivative of the inside function, f prime. Okay. And then finally, I finish the problem by solving for f prime. So f prime is equal to f times the natural log of 4. But what was f to begin with? Well, f was just 4 to the x. So I get 4 to the x times the natural log of 4. So there you have it, 2 relatively quick examples of how we can use the natural log and its properties to find the derivative of some exponential functions. So I'm going to end this video here. In the next video, we will talk about the third case, which involves an exponential function here and also another function. So we're going to use the product rule probably for this problem. As always, thank you for watching. Ask for help when you have clarifying questions, and have